Good database design is essential to build scalable, high-performance applications. A database is nothing more than a mass of information stored in a framework that makes it easier to search. Everything else is just details. If database works well, bits of related information are fetched automatically, and details can be pulled out as needed. It should be simple to draw new meaning from data by compiling it into reports and visualizations, then storing away those facts for later use. Within that simple definition, there is infinite variations. Small decisions in the beginning can have a huge cumulative negative impacts during the course of the project. Now, let's look over 10 database design best practices that can dramatically simplify the software development process. Consider every viewpoint during planning phase. Don't start building database without having all inputs from the project sponsor and other stakeholders. Get consensus on precise expectation and consider how hard it will be for users to adapt themselves to new design. Choose a correct database type. This is usually as easy as deciding between SQL and NoSQL databases. SQL databases are standard for structured data, when data integrity is absolutely important. Emerging technologies like machine learning or Internet of the Things find the speed, scalability, and fluid requirements of NoSQL databases as a better fit. Web analytics, social networks, and some other types of databases also work much better within the NoSQL framework. Make the decision as early as possible and stick to it. In reality, most companies today function in a hybrid world of SQL and NoSQL databases that work together in complex design. With such complicated structure, it is critical to normalize the data to achieve minimum redundancy. Eliminate multi-value attributes and repeated values. Make structures transparent. The database belongs to its future users, not its creators, so design with them in the mind. Stay away from shortcuts, abbreviations, or plurals. Use consistent naming conventions. Don't reinvent the wheel or make things difficult for those who may need to modify database at some point, which will certainly happen. Define constraints to maintain data integrity. Always look into full range of options to enforce business rules such as foreign key, check, not null, and the like. The application will prevent some bad data from getting in, but not all of it. Document everything. No matter how annoying it may seem, documentation is as essential as primary keys. Take care to document the design, entity relationship schemas, and triggers for the future users. Plan for increasing backup time in the build. Before delving too deeply into design, think about what happens during a natural or man-made disaster. Plan for failover clustering, auto backups, replication, and any other procedures necessary to ensure that database structure remains intact. As the saying goes, prepare and prevent. Don't repair and repent. Keep privacy primary. GDPR signals an era of increasing privacy concerns. Encrypt passwords and don't assign administrator without privacy training and well-documented qualifications. This can be a tricky rule to follow due to office politics, but as a good security practice, database should be as closed as possible. Vulnerabilities impact the data integrity, which impacts everything else in the enterprise. Optimize for speed. Create indexes for queries that will be used regularly. Use a database analyzer to determine if an index or clustered index is necessary. Consider incorporating tools like Elasticsearch to speed up search using caching. Keep the database on its own server. Put the database on a different server than the web or lower CPU usage servers. In addition to freeing up compute resources, it also helps to keep database out of the reach of unauthorized users. Remember, Database frameworks are not set in stone. The current database workflows can be refined and directed, or even broken up when it makes sense. Just as business directives change over the time, the database will also need fine-tuning to stay in line with the company's current business goals. Too often, administrators get bogged down in thinking about how the database functions at the moment without considering what it is capable of doing in the future. Instead of thinking it doesn't work like that, start from viewpoint of what is the end goal and how can we get there.